All right, so this last lesson of the year, integral to Riemann. So we have the integral from a to b of f of x. I'd suggest writing it down if you have it. Is equal to the limit as n approaches infinity. Sometimes they use k, sometimes they use n. From an integral from I equals 1. Oh, that's where they use k sometimes. So sometimes they use k right there. To n of delta x times f of x sub I, or x sub k. But we need to know what that delta x is and x sub I. So delta x is equal to b minus a over n. All right, so your limits, b minus a, over the number of partitions we're going to. All right, so over n. And then your x sub I is where your limit starts. That's where your a is. Okay, so that's your lower limit. And then plus delta x, which is the b minus a over n, times I, or k. All right? All right.
Okay.
So it's just that simple little formula, and we're going to go back and forth between an integral to a summation. They call it a Riemann summation because it's a left-hand limit. All right? All right, let's put it into practice. Everybody got that? All right, so this first one we have is the integral from 2 to 7 of x cubed. All right? So the integral from 2 to 7 of x cubed. So the first thing I need to find is delta x. All right? So what would delta x be? My b minus a over n, right? So I'd have what? 7 minus 2 over n. So I'd end up with 5 over n. All right? And now I need to get to, so now let's get to my x sub I. All right, so now my x sub I would be my lower limit, which is my a, so I'd end up with 2, and then plus my delta x, which would be what? 5 over n, and then times I. All right, and so now my f of x sub I is equal to, what is my function here? X cubed. So my function is x cubed, but instead of my x, it's going to be what? 2 plus 5 over n sub I quantity cubed. You following me? All right, so now I have everything in there. So now let's write out our limit statement. So now I have a limit as n approaches infinity, and I'm going to go from I equals 1 to n. And so now I end up having what? 2 plus 5 over ni over what? Or times what? 5 over n. Oh, that's cubed, I'm sorry. All right. And then we're done. All right, so I went from an integral to a Riemann summation. All right, let's do it again. So now I have an integral from 1 to 6 of x cubed plus 1. All right. All right, so what is my delta x? I don't need you to show all the steps here. I really don't. What's my delta x?
5 over n.
5 over n. All right, it's 6 minus 1 over n, right? And then what would be my x sub I? Where do I start? 1 plus what? 5 over n I. All right. And then my function would end up being what? The quantity of 1 plus 5 over n I quantity cubed plus 1. All right. And so now I'm ready to write my limit statement. So now I have a limit as n approaches infinity of my summation from I equals 1 to n of what now? So I'd have 1 plus 5 over n I to the power of 3, and then plus 1, and then that quantity is multiplied by what? 5 over n. All right, and so that's how we go from an integral to a summation. All right.
We find out what.
All right, so now we're going to go from an integral to a Riemann. Okay. Oh, we're doing that again. All right, so the same thing. All right, so we have an integral to a Riemann again. All right, so what's my delta x on this one? 4 over n, right? And so what is my x sub I? 4 over n I. All right? Because we're starting at 0 on this one. Yes? All right. So now my function, my f of x sub I, would end up being what? The square root of 4 over n I plus 3. All right. All right, so now let's put it in. So now I end up having my limit as n approaches infinity of my summation from I equals 1 to n. All right, and then I'd have what? What would my function be? Square root of 4 over n I, and then plus 3, and then times 4 over n. Okay? All right, so now we're going to go from a summation to an integral. All right, so let's write this one out. This one is using k's because a lot of the times they use k's or i's. All right, so I want to get you comfortable with both. All right, so now I have a limit as n approaches infinity of k equals 1 to n of 4 over nk plus 2 quantity squared minus 1 quantity times 4 over n. All right, so let's kind of go backwards on this. So I'm going to get an integral. So on these, I like to get my limits first. All right, so where is this one starting? It's starting at 2. It's starting at 2 because of that 2 right there. And then, what's the width? What's it going to? The width is 4, right? Because I got this 4 over n right here. Okay, so what's it going to? It's going to 6. All right, and then my x is just this part right here, right? And so my function would be what? X squared minus 1 dx. I'm going to skip a little bit here to kind of just go a little bit quicker. I think you guys are probably going to be comfortable with it in a little bit. All right, so on this first one, what goes out front? 4 over n, right? Yes? All right. And then what would be my x sub I? What's my x sub I? 4 over n I plus 0, right? And so then I substitute that in for x. So now I have 4 over n. I'm actually going to use k on these because that's what the answer choices are going to be. And then squared, and then plus 1. And I'm going to have a limit as n approaches infinity from k equals 1 to n. All right, and so now I need to look for that answer. So let's look for that answer. All right. And is it there? It's not there. Because look, there's our answer right there. It's 4 over n times k, quantity what? Squared. Okay, and we need to be able to recognize that that is the answer right here. Are you following me? All right. So sometimes they might square it. Sometimes it might happen to be a foiling. Okay, you have to recognize that on here. All right, so let's do this one too. All right, so what's my delta x? Pi over 2 over n. All right, so out there I'm going to have pi over 2 over n. All right, so pi over 2n, because that's what pi over 2 over n would be, right? Yeah. All right, and so then I'd end up with cosine of what? My x sub I, right? All right, so what's my x sub I? It'd be pi over 2 n, and then times what? Times k. All right, and then plus what? 0, but I don't need to put it. All right, and so that would be my answer I'm looking for. All right, so now let's look for that answer. All right, because that's a 2x, isn't it? All right, so we need to multiply that one by 2. I appreciate it. All right, that's a cosine of a 2x. All right, so now I look for that answer.
that's multiplied by 2, can't we just do pi over n?
That would be a pi over nk.
Wow.
All right. So we need to look for that answer. And so we found it on the next page. So now we're right there. Okay. All right. I'd like